we're going to look at an equilibrium problem that deals with salts, and we're going to look at two different applications of that. Many students find these very difficult because of the setup, the struggle with what equation they are using, and how they utilize the K expression that they are given. So let's take a look at our first example. It says find the pH of a 2 molar solution of KF. So, and then they give you a K value, and it says Ka of HF. So they're giving you a weak acid, and they're giving you that K value. So right there, that throws off many students because that usually leads them thinking that this is going to be an acidic problem. In fact, if you do this enough, you know that it's going to be the exact opposite. If they give you an Ka, that means that this is actually going to be basic. There's a couple other things. One, students have to recognize that this is a salt, right? This is a metal with a nonmetal. So you have to recognize, if they don't jump out and tell you this is a salt, that you need to recognize that's a salt. So a salt can break up into two ions. So in this case, here are the two ions that I'm utilizing. So either I'm utilizing the K or I'm utilizing the F. Well, based on the Ka value that they're giving me, they are saying that HF is going to ultimately be present in my equation. So if I'm looking at this, I know that all reactions have to react with water. Okay, so there's a couple things that could be going on here, but here's the essence of what I am struggling with. Is either it's going to make an H3O plus or it's going to make an OH minus. It's one or the other. So is this going to be acidic or is it going to be basic? Well, here's a little trick, and it's not perfect, but if you add OH to this and you add an H to that, this is a strong base. So this is a strong base and this is a weak acid. So what that tells me is that this solution is going to be basic. So because of that, I'm going to be needing OH minus. Okay, so if that's the case, my HOH, my water, has to be giving up that H to something. Well, H can only react and combine with something that is a negative in charge. So that means that I would have an HF on the right side, which is kind of a nice coincidence. And you'll notice the similarities of that is going to be present right there. Okay, so this is my equation. I set up an ice box. A lot of times an ice box is utilized to help me organize. Sometimes I need it for the entire problem. Other times I only need it to help me organize it in the beginning. So that is 2 molar of my F minus in a salt. A salt will break up into its ions. This is a very soluble salt, so that means that the ions will have the same molarity as the compound initially. That means I have 0 in the beginning of my products, so then this follows suit with how our ice boxes work. So let's shrink this ice box so we have room to work. So now we would have our expression, and our expression would be my products over my reactants. And here's the key. Because it's OH minus, this is a base. But right now I have a K value. So we have to remember something. That Ka times Kb equals 1.0 times 10 to the negative 14th at standard conditions. So I need to solve for Kb. So my Kb will equal my constant for water over my Ka. So my Kb is 1.39 times 10 to the negative 11th, which will be utilized right there. Because my initial value is more than 100 times than my Kb, I can cross off my X, and now my X is going to equal the concentration of my OH minus, which results in 5.27 times 10 to the negative 6. And now I just start rolling. POH equals negative log of the concentration of OH minus. And that'll get me 5.28. For some of you, you will stop right there. Please understand that if this is a basic problem, it should be greater than 7. So that should strike you as odd. So I need to take that and subtract it from 14. And I get a final pH of 8.72, which is basic, and that should make sense. So a solution of KF salt will have a pH of 8.72 if I have 2 molar of concentration. So here's our second example and our final example. Find the pH of a 1.2 molar solution of ammonium chloride, and then they give you a Kb. So again, you need to recognize that this is a salt solution. And as we're starting to learn this, you'll start recognizing the minute they give you a K value that it's probably the opposite in terms of being acidic or being basic. So the fact that I see a B probably means that it's acidic. So let's approach it that way once. So if I have done this for a little while now, I'm going to start recognizing, hey, this is going to be acidic. So instead of OH minus, I'm going to have H plus. So now you have to recognize I have H4 plus and I have Cl minus. Well, who can provide my H? The HOH gained an H. Also, if you're given a K value, it has to be present in my equation. So where does the NH3 go? And then it would make sense that I have to have an NH4. So does my NH3 and my NH4 go here? Or vice versa? Well, I have to make this make sense with my H's. So it looks like my water has gained an H. Well, this looks like this would be the logical choice, because NH4 loses my H, in essence, becomes NH3 on the other side. So here's my equation. Again, we set up the icebox, and this time I'm just setting it up enough for me. So my initial amount is 1.2 molar, 0, 0. Oh, if I have an initial amount and then there's zeros, that's the x squared over initial minus x. I am going to do that, but this is as far as I would need to go, because I've done these enough now that I recognize, I hope, same for you, that you would notice, hey, it's x squared over initial minus x equals, well, in this case, it's acidic, so it's going to equal Ka. So we need to figure that out. So reminder again, Ka is going to equal my Kw over my Kb. So I get 5.56 times 10 to the negative 10th, which is my Ka. And again, because my x is just my H3O plus, I know that x equals H plus, which is the same thing as H3O plus. I'm able to cross off my x and make that assumption, and I get 2.58 times 10 to the negative 5th. Well, because this is H plus, this is a more streamlined problem than last time, because I'm dealing with pH and H plus instead of POH and OH minus. I can simply plug this in into one step. I am saying that my solution is going to be acidic. My pH resembles that, so I feel quite confident. So these are two salt solution problems in terms of equilibrium. You have to recognize that the K is usually the opposite of the type of solution it's going to be in terms of acidic and basic. You need to convert that, and you need to take a moment and determine which ion is actually the active ion in my equation to produce the desired OH minus or the H plus.